The atmosphere, a thin, gaseous blanket surrounding Earth, is essential for life. It provides oxygen, regulates temperatures, and protects us from harmful solar radiation. This complex system is divided into 5 distinct layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere is the lowest layer of the atmosphere, extending from the Earth's surface to an average altitude of about 10 to 16 kilometers. It is the layer where most weather occurs, influenced by factors such as temperature, pressure, humidity, and wind. The troposphere contains most of the Earth's water vapor and air pollutants. Above the troposphere lies the stratosphere, extending from about 10 to 50 kilometers in altitude. This layer is characterized by a temperature inversion, meaning temperatures increase with altitude. The stratosphere is home to the ozone layer, a vital shield against harmful ultraviolet radiation from the sun. Ozone is a molecule composed of 3 oxygen atoms. When UV radiation strikes the ozone layer, it breaks down ozone molecules, but the molecules quickly recombine, absorbing the harmful radiation. The mesosphere extends from about 50 to 85 kilometers in altitude. It is the coldest layer of the atmosphere, with temperatures reaching as low as -90 degrees Celsius. The mesosphere is the layer where most meteors burn up, creating the phenomenon known as shooting stars. Above the mesosphere is the thermosphere, extending from about 85 to 500 kilometers in altitude. This layer is characterized by extremely high temperatures, reaching thousands of degrees Celsius. The thermosphere is where the International Space Station orbits and where auroras occur. Auroras are colorful light displays caused by the interaction of charged particles from the Sun with the Earth's atmosphere. The exosphere is the outermost layer of the atmosphere, extending from about 500 kilometers to the edge of space. It is so thin that there is little to no atmospheric pressure. The exosphere is where satellites and spacecraft orbit. The stratosphere, a layer of the atmosphere, contains the ozone layer, a vital shield against harmful ultraviolet or UV radiation from the sun. Ozone is a molecule composed of 3 oxygen atoms. When UV radiation strikes the ozone layer, it breaks down ozone molecules, but the molecules quickly recombine, absorbing the harmful radiation. Ozone depletion, a global threat. In the 1980s, scientists discovered a hole in the ozone layer above Antarctica. This depletion was caused by the release of chlorofluorocarbons, or CFCs, which were once widely used in refrigerants and aerosol propellants. CFCs rose into the stratosphere and reacted with ozone molecules, destroying them. The depletion of the ozone layer has serious consequences for human health and the environment. Increased UV radiation can lead to skin cancer, cataracts, and weakened immune systems. It can also harm plants and marine ecosystems. Pause 3's ozone layer recovery efforts. While the discovery of the ozone hole was alarming, it also spurred global action. In 1987, the world came together to sign the Montreal Protocol, an international treaty designed to phase out the production and consumption of ozone-depleting substances, including CFCs. This historic agreement marked a significant step toward environmental protection and has been hailed as one of the most successful international efforts to date. Thanks to the Montreal Protocol, the production of CFCs and other harmful chemicals has drastically decreased. Scientists have observed signs of recovery in the ozone layer, particularly over Antarctica. However, the journey to full recovery is ongoing, and continued vigilance and adherence to the protocol are necessary. Impacts of the greenhouse effect include rising temperatures. The Earth's average temperature is increasing, leading to more heat waves and warmer winters. Changing weather patterns. More frequent and intense extreme weather events such as hurricanes, droughts and floods. Melting glaciers and rising sea levels. This poses a threat to coastal cities and low-lying areas. Loss of biodiversity. Many species are struggling to adapt to changing conditions, leading to habitat loss and extinction. And finally, ocean acidification. The increased carbon dioxide in the atmosphere is absorbed by the oceans, making them more acidic and harming marine ecosystems. International efforts to protect the ozone layer. Recognizing the threat posed by ozone depletion, nations around the world came together to address the issue. The Montreal Protocol, an international agreement signed in 1987, established a framework for phasing out the production and consumption of CFCs and other ozone-depleting substances. Thanks to the Montreal Protocol and subsequent amendments, the ozone layer is gradually recovering. However, it will take decades for the ozone hole to fully heal. The greenhouse effect and climate change. Another major environmental challenge facing the Earth is climate change, driven by the enhanced greenhouse effect. Greenhouse gases such as carbon dioxide, methane, and nitrous oxide trap heat in the atmosphere, leading to rising temperatures. This warming can cause significant changes in weather patterns, sea levels, and ecosystems. Human activities, such as burning fossil fuels and deforestation, have contributed significantly to the increase in greenhouse gas emissions. This has led to a warming trend that is accelerating climate change. Mitigating climate change. To address climate change, it is essential to reduce greenhouse gas emissions. This can be achieved through a variety of strategies, including transitioning to renewable energy sources. Solar, wind, hydro, and geothermal power can replace fossil fuels and reduce carbon emissions. Improving energy efficiency. By using energy more efficiently in homes, businesses, and transportation, we can reduce overall energy consumption. Protecting forests. Forests absorb carbon dioxide from the atmosphere. Preserving and restoring forests can help mitigate climate change. And finally, adopting sustainable land management practices. Sustainable agriculture and land use practices can reduce greenhouse gas emissions and protect ecosystems. Pause 3. The journey of Krishna Swamy Das. Amidst our discussion on climate change, let's take a moment to explore a different kind of journey, one rooted in the passion for cricket. Pause 2. Krishna Swamy Das, a book written by me and my friends Arav and Aditya, dives deep into the world of cricket. It's a tale that captures the essence of the sport, the struggles and the triumphs of a cricketer named Krishna Swamy Das. Pause 2. This book is not just about cricket. It's about life, perseverance, and the spirit of sportsmanship. Inspired by our shared love for the game, we set out on a journey to pen down a story that would resonate with cricket enthusiasts and those who admire stories of grit and determination. Pause 2s. The writing process was a collaborative effort, filled with late-night brainstorming sessions, countless revisions, and a lot of laughter. Each chapter is crafted with care, reflecting our collective experiences and the inspiration we drew from legendary cricketers. Pause 2s. Krishna Swamy Das is more than a book. It's a tribute to the game we love and a gift to all cricket fans. We hope it inspires you as much as it inspired us while writing it. Pause 2s. Available now. Krishna Swamy Das is a must-read for anyone who loves cricket and appreciates a good story. Join us on this incredible journey and discover the world of Krishna Swamy Das. Pause 3s. Thank you for watching, and don't forget to check out Krishna Swamy Das. Check the link below for purchasing the book according to your nearest country.